Hi, everyone, and welcome back to our second session of this morning's Data Bootcamp. I'm here to talk to you about demystifying buzzwords, what all the buzzwords that you may hear swirling around mean, and what you should actually care about. For those that missed our brief introduction this morning, my name is Ben Kirshner. I'm an applied data science lead on our political advocacy at nonprofit team at Civis Analytics. And I've worked with a large swath of nonprofit organizations across the gamut of data science, from reporting and ETL work to predictive modeling to survey research, and really excited to share with you some thoughts on all the buzzwords we've encountered along the way. As you may know, there are quite a few buzzwords flying around, and there are, in fact, too many to cover in the brief time that we have together. So as to avoid just rifling off definitions at you for about 20 minutes, I've curated a list of what I think are the most common, useful buzzwords to understand, and hope in going through those, I'll be able to also provide a brief overview of the concepts they capture. In particular, what I'd like for this session to do is to show how all these buzzwords actually relate to each other, as opposed to having them just be one-off words that you might hear, and provide a framework for thinking about how these buzzwords relate to your organization and your organization's data goals. So in particular, I've categorized buzzwords into 4 key areas: disciplines, technologies, methodologies, and management, and we'll go through them in that order. So to start, the reason why we are here today talking about data and talking about these buzzwords is because these buzzwords are part of a relatively new and rapidly evolving discipline, that discipline being data science and data analytics, that help organizations get smarter and more efficient. Anna Berman, my colleague in our previous session, gave a great overview of analytics, so I'm not going to spend too much time there. But from a high level, did want to say that analytics, business intelligence, or data science are really about the art and science of drawing actionable insights from data. The reason I want to start here is because understanding what all these buzzwords means understanding the field with which they derive. So to dive a little bit deeper into data science is really 3 things. Data science solves organizational problems through the discovery of data insight and the development of data products. It is an end-to-end process that involves capturing, processing, analyzing, and communicating about data. And it is a multidisciplinary field that requires people with different skills and backgrounds to be successful. The session on building data science capacity a little bit later will cover a lot more detail around this, as well as what different roles are pertaining to data science. But I think it's helpful to keep these things in mind as we go through the buzzwords, particularly development of data products, discovery of data insights, multidisciplinary field, and end-to-end process. But to bring that back to our first set of buzzwords, if I were to differentiate slightly between data science and analytics, in data science, you might see a slightly more focus on predictive applications, potentially more traditional programming or software engineering. On the analytics or BI side, that is business intelligence, the focus might be a little bit more on identifying trends with historical data, producing reports or visualizations, and a lot of this happens with SQL. Again, some later sessions will focus a little bit more on what these roles are and who to look for in those capacities. So with those disciplines in mind, the next set of buzzwords that I want to cover pertain to technologies. These are the infrastructure that support data. And really, as Anna also mentioned, unlocking the benefits of data require it to be both accessible and usable. And there are a slew of technologies that help do so. In particular, there are 3 what we'll call buzzwords that I want to highlight with regard to technology. These are all infrastructure that support data work. The first is data warehouse. A data warehouse stores structured data in a relational database. Well, I might have just used a few more buzzwords to describe a buzzword, so let me unpack that a little bit. Structured data you can think of as any data that has rows or tables, such as a CSV file or something that would fit in Excel or Google Sheets. And relationship just means that there are multiple tables with some common identifier. Maybe that's contacts and accounts, and an account has a contact as a common identifier. Structured tables, or often the data that's found in a data warehouse, is usually designed and optimized for business intelligence or reporting. It ingests data from various source systems that you may have and puts them into a central repository. A subset of a data warehouse is what might be called a data mart. A data mart is really a set of tables that are really designed for reporting or analysis. So they're clean, they're aggregated, they're a place that all analysts or others at an organization can look to know that that is a source of truth for business intelligence or analytics. The last technology buzzword or infrastructure really buzzword that I want to cover is data lake. You may have heard this term thrown around. A data lake, simply put, is a repository that can store any and all data as it is. So a data lake can store structured data, much as a data warehouse. It can also store what we call unstructured data. Think of anything that's not rows and columns. Maybe this is a screen grab of a conversation or another image. A data lake can store all of that and is oftentimes used for more machine learning applications because of the depth and variety of data that's available in a data lake. I will say, as we look at the current data landscape, we do see increasing overlap of these two technologies, really harnessing the benefits of both the flexibility and diversity of a data lake with the data warehouse being optimized for analytics or transactional purposes. Some other technology buzzwords that you might have come across is a data stack. A data stack is a set of tools or technologies that enables analytics, particularly for transactional data. And I have here a simple data stack just to provide an example of what this might look like. We do have a full session on a modern analytics stack in the afternoon that I encourage you to check out. But a data stack is essentially the grouping of technologies that is going to support your data work. It supports what is traditionally called ETL, or extract, transform, load, the process of taking data from various systems, bringing it or transforming it into its usable form, and bringing it into a centralized repository or warehouse. That could be a warehouse or that could be a data lake. I do want to note, because data storage is becoming increasingly available, that we're actually, as we're talking about buzzwords, of which ETL could be considered one, seeing a paradigm shift from extract, transform, load, ETL, to ELT, extract, load, transform, where you don't have to worry quite as much about cleaning the data before you pull it into that centralized repository. This is especially true of lakes because that data storage is there. And then once it's there, you can figure out how to best optimize it. That allows you to focus on the kind of most important use cases for your organization rather than spending all of the time just preparing a data warehouse. The last technology buzzword that I want to cover is what we call AI or ML ops. Think of this as a subset of your data stack, specifically focused on building and deploying models. Maybe you've heard of productionizing models. What this really means is something like scoring a new donor when they inbound, perhaps on their likelihood to become a sustaining donor, and targeting communications accordingly. Or it could be an interest model that ensures, or an affinity model that ensures your supporters are being surfaced the stories and the communications that they'll be most compelled by. AI and ML ops I wanted to bring up because increasingly we're hearing conversations around productionizing models in that way. Which brings us to models, my third category of buzzwords. So now that we've covered the technologies that empower data work, it really is, in addition to cleaning and standardizing data, methodologies that are grounded in statistics that make the data actionable. And that is my third category of buzzwords. I will say that sometimes it seems like there is a black box around a lot of these methodologies. I want to do what I can to just unpack a little bit of what that black box is and the buzzwords associated with it. In particular, there are 4 buzzwords that I want to focus on. The first being artificial intelligence. Certainly you've heard artificial intelligence. It's actually a fairly poorly defined term, but I like to think of it as computers that can learn and make smart decisions on their own without human input. Importantly, when we think about data applications at nonprofit organizations, where you'll probably be engaging is more in the realm of machine learning. And if you think about the relationship between artificial intelligence and machine learning is really a subset of artificial intelligence. It is a specific process by which computers learn patterns in data, again, without explicitly being told what to look for by a human. One key thing about machine learning is that it is a set of algorithms, and we'll get to algorithm in just a second, that must be trained on data. As we think about the AI element of it, it's really because the more data you provide to your algorithm, often the better that algorithm is going to get. Hence, it's going to start learning, provided that you, again, have cleaned the data and inputting it in a usable form. I like to think about machine learning as taking in data and learning things about it, or recognizing patterns that a human could identify if you had infinite time and resources, but in actuality are really difficult for humans to achieve because of computational scale. So machine learning relies on computational resources to take in data and learn and deduce patterns through that data. Machine learning encompasses quite a few types of algorithms. This is my next buzzword, essentially a machine learning algorithm. Algorithms are programs that can learn from data and improve from experience. And as we kind of funnel down, algorithms are specific to a certain type of learning. So other buzzwords that you might have heard could be supervised learning or unsupervised learning. These represent different types of algorithms that fall under machine learning. Supervised learning is a case where an answer is known, and so you might be trying to predict a known outcome, for instance, a diagnosis. And unsupervised learning is learning, machine learning, where the outcome is not known. Say we just have a group of data and we want to cluster it or segment it in a way that makes sense and represents some underlying patterns. But a priori, there's no determined pattern that is right or known. Finally, my last methodological buzzword is a predictive model. A predictive model is the result of machine learning and a machine learning algorithm. What it really does is it just aims to predict a specific outcome based on existing data and the patterns of that existing data. A predictive model example might be a likely sustainer model or a likely donor model or a likely activist model, someone that perhaps is prone to sign a petition for your organization. Again, to highlight the relationships here, I really do like this graphic. This whole graphic, starting with historic data and ending with predictions, represents machine learning. So if AI were to be represented on this slide, it would be kind of a bubble that goes around the whole slide and then some. But this graphic itself represents machine learning. And in particular, you can see where algorithms and predictive models come to play. So an algorithm helps take your historic data and generate a predictive model from it. A predictive model then can look at new data and generate predictions. And again, that whole set of, that whole process encompasses what is machine learning. The last category of buzzwords that I want to focus on is what I'm calling management. And one of Anna's takeaways, I think, from the previous session too, was that sound management, having a strong foundation, is really key. And in fact, it ensures trust and adoption. And because of that, there are 3 buzzwords that you, again, may have heard that I want to focus on with regards to sound management. The first is data governance. Data governance are practices and processes, including designating owners of data, that ensure both formal management and proper use. At its core, data governance ensures that your data is of quality and you are compliant with any data needs. That's particularly important as we think about increasing privacy concerns around PII, or personally identifiable information. The next buzzword I want to focus on is data lineage. There's a lot of development going into tracking data lineages. What is a data lineage? Data lineage is essentially the journey your data takes from where it is generated to collected to transformed to used. And if data governance is really about quality and compliance, data lineage is about ensuring that anyone that is using that data has the context around that data. And data context, again, could be its whole other presentation, is really important. But when you hear data lineage, you can think about that in terms of ensuring that the context around the data is understood. And lastly is a data catalog. A data catalog is essentially a collection of metadata that serves as an inventory of all your organization's data. Again, if data governance is about quality and data lineage is about context, a data catalog is really about documentation and accessibility, making sure that individuals know what's available to them and can easily find it. Now, I almost made it through this whole presentation without mentioning probably the buzziest of buzzwords, which is big data. And that's intentional, partly because big data has so many definitions, but partly because I think in this day and age, particularly for nonprofits thinking about how they engage with donors, big data is less relevant as a buzzword. What is big data? I think a simple definition of big data is that it's data that's too big to be processed with kind of existing or traditional computational methods. But the reason I really don't want to spend too much time here is because advancements in cloud-based data storage, going back to the data warehouse and data lakes I was talking about, and the shifting paradigm from ETL to ELT, have just put about really all analysis that nonprofit organizations would want to or dream of doing, at least in terms of kind of interacting with donors as opposed to, say, more kind of scientific research, very much in reach. So when we think of big data, I don't think it's as useful a construct to think about in the case of buzzwords anymore. And with that, I want to leave with a few parting thoughts as it pertains to buzzwords. You may have heard throughout publications or in your own organization something like, organizations will need to be data-driven in order to survive. And that's because, as you know, creating and sustaining relationships with your supporters, your constituents, your donors is key to organizational health. And data can certainly help do that. When I reflect on the current state of buzzwords, especially as I was just thinking about big data, technology has really developed to the point where your conversation doesn't really need to focus on how will I manage my data volumes, but it can focus much more on what is encapsulated by these buzzwords. How will I ensure I have good quality data? How will my technology and methodologies support my desired outcomes? And what are those outcomes, and what data do we have that can help towards achieving those outcomes? And as a final thought, I don't think it can hurt to have everyone in your organization on the same page about those concepts to facilitate that conversation. So I hope going through some of these buzzwords was a useful exercise. Finally, as we will be posting these sessions, I did want to reference a few resources in case you are interested and want to take a deeper look, whether it is into the changing data landscape and current trends, or get a little bit more in the weeds on these buzzwords. So those will be made available. And thank you for listening on Data Buzzwords.
Thank you, Ben. As I'm hearing you go through this, the acronyms, one of the first questions is, how do you keep them all straight? There's so many.
That is a great question. I have the benefit of being with these acronyms all day, every day, which I recognize is probably not the most helpful answer for someone that's just starting. I think what I would say, and this is something that we run into at Civis internally all the time, because as you can imagine, we have all of the data acronyms as well as all of our internal acronyms, is we use a lot of acronyms. And I would really just encourage you, if someone is using an acronym that you're unfamiliar with, to speak up and ask, hey, what? My hope was that this session started from some of the basics, but I'm certainly happy to clarify too any acronyms that I might have inadvertently shared along the way.
Actually, I think you did a really fantastic job of defining them. So thank you for that. One concept I do want to circle back to is this idea of the data lake. And what is the best way to optimize the data once it's been placed in the lake? I think, you talked about the fact that now there's cloud, folks are dumping a lot more of their data in before it's cleaned and scrubbed. Have you found a way to, or a method that's helpful in optimizing all of the data once it's placed there?
That's a great question. Without getting too technical, I think one of the key differences between a data warehouse and a data lake is that a data warehouse, you have to specify what's called a schema on write. In other words, the data has to be structured in order to go in. And if you don't tell it what that data looks like, it's going to yell at you. Data lake does not require that. It does what's called schema on read, where you can just throw anything in there. And when you pull it out, that's when you specify the schema. There are increasingly a lot of tools that help you understand what's in there and how to use it. And those are actually what are called data catalogs that I spoke to. To not kind of meld this all together, increasingly data catalogs are using machine learning techniques to scan what's in the data lake, process it, and produce metadata for you to then be able to access what's in there. So I think as a kind of starting place, would definitely recommend checking out data catalog solutions. Oftentimes they're built into data lakes as a way of ensuring that you have at least some understanding of what's in there.
Thank you, Ben. That's really helpful. And one last question as we're closing. You mentioned this idea of not taking data out of context when you were speaking to data Lineage. And do you have any thoughts or suggestions for when someone might know that they are taking data out of context?
That's a great question. I think to encourage making sure that you're not taking data out of context, you can always be curious and asking questions about the data. Even simple things like, when was this collected? Who was it collected by? How was it collected? Is there any incentives around how it was collected? If you are able to answer those questions about your data, you're at least on the road to understanding the data context. If instead you're working with data and you realize that you don't know the answers to some of those questions, maybe it's time to pause and think about, where did I get this data from? Who did I get it from? And how can I start to answer those questions so that you're not missing something crucial in your analysis?
Thank you, Ben. That is very helpful as folks think about what the next step might be for them as they collect data within their org. Certainly want to thank you, Ben, for sharing your wisdom and knowledge with us. We do have a question that came in from Jonathan. I do want to slip this in at the last moment. It actually sounds kind of fun, so get ready. What is the most interesting project you've worked on that involved connecting seemingly disparate data? This may take a little longer than we have, but if you can think of one quickly, it seems like it could be fun.
I'm racking my brain. I can certainly follow up with a specific project, but I think a lot of what we do for nonprofits is connect data from different source systems. So conceptually, it's not disparate. One source system might be email or digital activation. One might be a CRM. But in practice, they're very disparate because they're run by different teams for different programs, and being able to connect those together to provide a holistic view into how an organization engages with donors is really fascinating and lays a really strong foundation for subsequent analytics work.
Thank you, Ben. Thank you for your time. Thank you for sharing. Certainly this, I think, very informative. And we are going to keep the information train going. Our next session is moving from Google Sheets to data tools. So we'll start that session in a moment.